Unit 9B, check your understanding. Let's take a look at this one. It says for this assignment, we're doing the following 6 quadratic functions. We work through examples, a couple of examples like these in class. So now it's a try it on your own time here. So for this assignment using these. So on our first one, step number 1 is make sure that these are in standard form because we're basing everything off of y equals ax squared plus bx plus c. Okay, so we've got a quadratic term with a quadratic coefficient that we call a linear term with a linear coefficient that we call b, and a constant term that we call c. All right, so in our first one here, y equals ax squared plus bx plus c. The a, there's no number there, so that means it's a 1. So the a in that case is 1. I'm going to do my a's. I'm going to try to switch between colors here. I don't know how. No, I'm not. I'm not going to worry about the colors. The a is 1. The b is 12. The c is negative 9. In this one, quadratic linear constant. So the a is negative 2, the b is 16, the c is negative 1. Quadratic linear constant in, so the the quadratic coefficient is 3, linear coefficient is negative 24, and the constant is 7. This one is not in the right order. This goes linear, constant, quadratic. Standard form is negative 5x squared plus 10x plus 8. And now I can correctly identify the a as being the negative 5. The b is 10. The c is 8. If I don't get those right, then what I'm going to be doing with these numbers is not going to work. Okay, another leading coefficient of 1 in the quadratic. The linear is negative 3. The constant is 2. Quadratic one is negative 2, linear is negative 10, and the constant is negative 9. Okay, so that doesn't do a whole lot for me all on its own, as far as I can tell so far. But now I'm going to go down and I'm going to use those. Okay, so for a, this says x is equal to the opposite of b over 2a. So this is finding the equation of the line or axis of symmetry. They mean the same thing. It's an equation. They've already given me the x equals part because it's a vertical line, so it should be x equals some number. And that number, for reasons that we will develop in Algebra 2, but we're just going to give to you right now, is going to be the opposite of whatever the b was. My first b was 12 over 2 times whatever the a was. So order of operations says I got to do 2 times 1 first and get a 2. So this is a negative 12 over 2. 12 over 2 is 6. So that is negative 6. My equation for the line of symmetry on the first one is x equals negative 6. Okay, it's going to continue on with that. Make sure my focus is where I want it to be. So in B, x equals the opposite of the b, which was 16, over 2 times the a, which is a negative 2. So that's the opposite of 16 over 2 times negative 2 is a negative 4. Could go a couple of directions on this. I see a negative and a negative. Those two negatives together will make a positive. 16 divided by 4 is 4. So x equals 4 is my equation for the line of symmetry there. For C, x equals the opposite of b, which is a negative 24, over 2 times the a, which is 3. Notice c does not get mentioned in here anywhere, so I'm just kind of ignoring these numbers for now. They don't do me anything here. So that's the opposite of, well, I got the opposite of the negative. Those two negatives I can make a positive. So this becomes a 24 over 2 times 3, which is 6, which is 4. So this axis of symmetry is also x equals 4. X equals the opposite in D of b, which is 10 over 2 times negative 5. That's an opposite of 10 over negative 10. The two opposites cancel each other out. 10 divided by 10 is 1. So x equals 1 is the equation for the axis of symmetry. And E gives me a negative 3 over 2 times 1. Negative negative is positive. 3 divided by 2 is 3 halves, 1.5. I like fractions. So x equals 3 halves is where the axis of symmetry is there. It doesn't always have to be at a whole number. I choose a lot of them that will work out that way for you, but it doesn't have to be. The opposite of b, which is negative 10 over 2 times negative 2. Those two negatives will make a positive. It gives me a 10 divided by negative 4. That's going to be negative, and that reduces to a 5 halves. So x equals negative 5 halves is where that axis of symmetry is. All right, flip it over. There's going to be a lot of flipping of things here. So use the input value to find the location of the vertex. So we found equation of the axis of symmetry over here. That was one of our vocab terms. Vertex was another one of our vocab terms. So the first thing I'm going to do is I'm going to come along here and grab the input values from part 2. We know the axis of symmetry passes through the vertex, so these x coordinates I'm going to need. Negative 6, 4, 4, 1, so a negative 6, 4, 4, 1, 3 halves, and negative 5 halves. Probably end up going to the decimals there for what I'm going to do. We're going to use these as the inputs to the equations. So equation A was x squared plus 12x minus 9. Remember that. So something squared plus 12 times something, did I say minus? Yes, minus 9. And I'm going to put a negative 6 in to those parentheses. Negative 6 times negative 6 is positive 36. 12 times negative 6 is negative 72, so I'm going to be subtracting 72 and then subtracting 9, which if I punch that into my calculator, I believe I get a negative 45. Negative 36, yes, negative 45. So that's the y-coordinate. This first one has a vertex at negative 6, negative 45. Might be difficult to plot that one on the graphs that I have. Okay. Second equation, negative 2 times something squared plus 16 times something and minus 1. I plug a 4 in to those. This is going to give me negative 2 times 16 plus 16 times 4 is 64 minus 1. So that's a negative 32 plus 64 minus 1, which I believe is 31. So this one has a vertex at 4, 31. Next equation, 3 times something squared minus 24 times something, and plus 7. 4 is the input that I want to use for those. So that's going to be 3 times 16, which is a 48. 24 times 4 is 96. You could be using your calculator on this if you wanted to. Plus 7. Negative 48 here plus 7 gives me a negative 41. So 4, negative 41 is where that vertex is going to be. For D, I can use it in any form that I want here. I'm going to use my standard form. Negative 5 times something squared plus 10 times something. And plus 8. I got that right. Yep, mostly positives. And a 1 drops in. That's nice. 1 squared is 1, so that gives me a negative 5 plus 10 plus 8. 18 minus 5 feels like a 13, so 1 comma 13 is where that vertex is located. E, something squared minus 3 times something plus 2. I could do this with decimals or fractions. You know me, I love a good fraction. So that's going to give me a 9 over 4 minus 9 over 2 plus 2, which is 9 over 4 minus, I can rewrite this as an 18 over 4, which would give me a negative 9 over 4 plus 8 divided by 4 is 2, so or 8 divided by 4 gives me the 2. So 8 minus 9 is a negative 1 over 4. That vertex will be at 3/2 comma negative 1/4. Negative 2 times something squared minus 10 times something. And a minus 9 at the end of that. Drop a negative 5/2 into those. So that's a negative 2 times 25/4 minus plus, because it's a minus and there's a negative in there, 50/2 minus 9, which I'm going to write as 18/2 because I think I'm going to need that anyway. This 2 can cancel and make that a 2, so I have 50/2 minus 25/2 minus another 18, so that's 25 minus 18, which is 7/2. So negative 5/2 comma 7/2 is where that vertex is going to be located. Okay. That was the bulk of the work. Okay, that's the hardest thing, is coming up with the y-coordinates of the vertex. At least it's the most amount of work, the most places where you have to be careful that something doesn't go wrong. Okay. Now, use the y-intercept and the location of the line of symmetry to find one other point on the parabola. So, my y-intercepts, I'm going to go ahead and load in my y-intercepts here first. So y-intercepts are always 0 comma something. And if we were drawing these, we did this kind of thing on the U9A check your understanding. If I put zeros in, I can see where my equations are up here. If I put zeros in, everything that had an x is going to go away, and this is where my c values come in. These are all just going to be all of my c values, the negative 9, the negative 1, the 7, the 8, the 2, and the negative 9. Okay. Now, my axis of symmetry, again, was located here at x equals these things. So my axis of symmetry, I had an x equals negative 6, an x equals 4, x equals 4, x equals 1, x equals 3/2, and x equals negative 5/2. If I drew a little picture here a little bit, I've got the axis here at x equals negative 6. Okay. And so that's a gap to this side of 6, and I've got a point down here at 0 comma negative 9. So the y-coordinates of these other points that I'm going to know about are going to be the same as the y-coordinates of my y-intercepts. So negative 9, negative 1, 7, 8, 2, and negative 9. And this, from 0 to negative 6 was 6. If I go another 6 to the left, I'm going to be at negative 12. So I know that negative 12 comma negative 9 should also be on that graph. This one, if the axis was at 4, then that's 4 to the right of the y-intercept, I need to go another 4, which would kick me out to 8. So it feels like the pattern is I'm doubling whatever these values were. So that's also going to be at an 8. 1 would then, the next point to the right of that would go to 2. 3 halves, if I double that, is just a 3. And if I double negative 5 halves, I get a negative 5. Okay. So that is all of that information for that one. A little bit of work to do, but if we stay organized and we remember the stuff from Standard A, then this is just kind of coming up with those numbers without having the picture in front of us.